Alright guys, so I'm going to go over the study guide here in case you guys had any questions. You do not need to watch this video. It's just me going through the problems in case you got stuck on one of them. So let's take a look at number 1 here. Sketch an example of a linear function that's increasing. So if I make a graph, a linear function that is increasing is one that slopes upwards in that direction. So that would be an example of a linear function that is increasing. And then, of course, a linear function that's decreasing would be one that slopes downwards from left to right. And then a constant function would be one that is horizontal. Number 3, write the equation of a linear function so that it's increasing. What matters is the number you put right here. If you put a positive number, that's increasing. And so for number 5, we're going to ask us to find a decrease to write the equation of a decreasing function. If I change that 2 into a negative, then it's decreasing. Now, one that's constant is one where technically the number in front of the x is a 0, so we don't even bother writing the x term. And we just have the constant there. So it doesn't matter what this number is, so long as there's no x in the problem, it's y equals a number, that would be a constant function. Same question, but now from the perspective of tables. So determine if the linear function below is increasing, decreasing, or constant. So we can kind of ignore the x values. Now, just as a side note, what I'm about ready to tell you only applies if your x values are getting bigger from left to right. But that's all I'm going to give you for now. All 3 of these problems, the x values are increasing, so that doesn't matter. So what you really want to look at is what's happening with the y values. Are the y values getting bigger or smaller as we move to the right? So 1, 0, negative 1. So that's a decreasing function because the y values are getting smaller as we move from left to right. Here, the y values aren't changing, so that would be constant. On this one, 1, 2, 3, the y values are increasing, so that would be an increasing function. Okay, so you should know whether a function is increasing, decreasing, or constant, whether you're looking at a graph, an equation, or a table. So that's some questions that you might want to be aware of. Let's go ahead and move on to the next ones. Where was I? I lost my place. There we go. Sketch a graph. Okay, when you're sketching graphs, you need 3 numbers. You need a rise, you need a run, and you need a y-intercept. In this case, there isn't one, so it would be a 0. So for number 10, my y-intercept is 0, so I would start at 0 on the y-axis, and my slope is 2/5, so I would go up 2 and over 5 from my y-intercept. So rise 2, run 5. Rise 2, run 5. Now you don't need those dotted lines. What you need is a dot here where you land, and then a line that connects those. So that would be the graph of number 10. Let's take a look at number 11. Number 11 is missing a number as well. We need a rise, a run, and a y-intercept. We have our y-intercept. We have our rise, but we don't have our run. So when that's missing, it's a 1. So for number 11, we're going to start at negative 3, and I'm going to go up 5 over 1. Rise 5, run 1, connect the dots, and we're good to go. Number 12. This is not in y equals mx plus b form. So when you have an equation that's not in y equals mx plus b form, you need to get it in that form. And the way we do that is by moving the x to the other side like so. And now we can graph it. We have our rise. We have our run. Make that a fraction mark. I'll put the negative here. And we have our y-intercept. So they're all 1. So I'm going to start at 1 on the y-axis. Now this time, since my slope is negative, what that means is for my rise, I'm actually going to go down. But we still go to the right. So starting from my y-intercept of 1, I'm going to go down 1 over 1. And there's my graph. Let's take a look at number 13. Same thing as number 12. We need to get the y by itself. So if I wanted to get the y by itself, we have a little bit more work on this one. The first thing we need to do is we need to move the 5x to the other side. So that takes care of the 5x. We also need to get rid of this 3. So now I've got this. The next thing we do is get rid of the 3 in front of the y. The way you're going to do that is by dividing everything by the 3. And now we have the following equation. -5/3 x plus 1. So we're ready to graph it now. My y-intercept is 1. My rise is a negative, so that means I'm actually going to go down 5, right 3. So down 5, right 3 from my y-intercept. And there it is. So let's take a look at number 14, I mean. For number 14 and 15, both of these are missing a variable. Whenever it's x equals a number, what you're going to do is you're going to find that number on the x-axis. So if x equals 4, I'm going to find 4 on the x-axis, and you're going to draw a vertical line through it. You don't need to write this for this problem, but I will say that lines like this have no slope. For number 15, that's 14. For number 15, when you have y equals a number, you're just going to find that number on the y-axis, and you're going to draw a horizontal line through it. And lines like this have a slope of 0. So that's graphing lines. All right, number 16. Which line has the greatest slope? The red line, the blue line, or the green line? Well, first of all, the red line is sloping upwards. That has a positive slope. The blue line also has a positive slope. But the green line slopes downwards. It has a negative slope. So obviously positive numbers have to be bigger than negatives. So we know it's not the green line. So we'll just cross off that one. So now which one's the greatest slope? Is it the red line or the blue line? Well, the steeper it is, the more positive it is. Now since the red line is more steep than the blue line, that would mean it's a greater positive number than the blue line. So therefore, the answer is red. Now, if I were to ask you guys what is the least steep or the least slope, you would go with the number that is. You would go with the line that has the steepest negative slope. And don't forget, horizontal lines have a 0 slope. So there's no horizontal lines on this problem, but you get the idea. All right. Let's go ahead and write number 17. Write the slope-intercept form of this slope-intercept form of the equation of each line. I'm not too sure what these little dots are doing on the graph. I think that's a typo. We can ignore those. So there's a long way and a short way. I'll do the long way first. The long way is to pick 2 dots on this graph. So like, let's say I picked this one here and this one here. And you want to know the coordinates of those points. So the one in the top left is -3, 0. The one down here that I chose is -2, -1. We can call this x1, y1. We can call this x2, y2. And we need to start by finding our slope. And then we'll find the b. And then we can write our equation. So to find your slope, you're going to do y2 minus y1 over x2 minus x1. Double negatives become positives, and so the slope is -1. To find your b value, you're going to take the formula y equals mx plus b, and you're going to plug in something here, here, and here. So for the y and x, you're just going to use one of your points. So I'll use that point. So for y, I'll plug in 0. And for x, I'll plug in -3. For the m, you're going to use the answer that you got in the first step. So we have 0 equals -1 times -3 is +3 minus the 3 on both sides, and you get negative 3. Once you have that, you can just take to find your equation, all you need to do is you need to put the slope that you found in the first part here, and you need to put your b value, the y-intercept that you found in the second part there. So we have negative 1x minus 3 is the equation of that line. Now another way you guys could have done this problem without so much calculation is you could really just look at this and say, okay, the y-intercept is negative 3. Now I just need my slope. The slope, pick any 2 points. As you can see, it's down 1, which is negative, and right 1, which is positive. Negative 1 over 1. So rise over run. Negative 1 over 1 is negative 1. So much faster if you just do it that way. However, this method works on every problem I give you. So that's why I like to go through it. All right. Let's go ahead and move on here. Write the slope-intercept form equation of the line through the given point with the given slope. So on this one, we're asked to find the equation, and once again, you need a slope, you need a b, and then you can write your equation. Okay? Well, on this problem, it's actually a little bit easier. They actually just give you the slope. So there you go. Simple. Then, to find our b, we're going to do the same thing we did in the last problem. We're going to plug in a y value, which in this case is 4, and then our m value, and then our x value, which is negative 5, and our b is still unknown to us. Now, in this case, put that over 1 and multiply straight across, you get 20 over 5. And 20 over 5 just reduces to 4. Minus the 4 on both sides, and you get b equals 0. So our equation would look like this. Y equals my slope plus 0. Now, if on the multiple choice test, they probably will not include the 0, just so you know, because if your y-intercept is 0, there's no point in writing it. So that would be our final answer. Let's go ahead and take a look at number 19 now. So same thing, we want to find the slope-intercept form of the equation there. Okay, so number 19, here we go. In this case, they give us 2 points. So we're going to do this one a lot like the way we did the one with the graph. You're going to start by labeling the points, x2, y2, and x1, y1. Then you're going to find your slope, your b, and write your equation. So in this case, they didn't give us the slope, so we have to calculate it. So it's y2 minus y1 over x2 minus x1. Double negatives are positive, so that's going to be 7 over 1, which just is 7. Now to find the b, pick a point. It doesn't matter which one. I'll go with this one. You're going to plug in the 3 for y, you're going to plug in the 3 for x, and you're going to plug in the 7 for m to our slope-intercept equation, right? So if I plug in 3 for y, 7 for m, and 3 for x, we can solve for b. So b is negative 18. Now that we've done that, we can write our equation. We take our answer from the first part and our answer from the second part, and we just put them in the equation like so. And there's our final answer. All right, let's go ahead and take a look at number 20. So on number 20, they want us to find another equation. Once again, we're going to go through the same process as we did with the last few problems. We're going to need a slope, a y-intercept, and then we can write our equation. Now, here's what's different, though, about this one. They give you the slope, but they kind of give it to you in a low-key way. So, Here it is. They're telling you that the line you want to find is parallel to this one. Here's the secret. Parallel lines have the same slope. So what's the slope of the line they gave us? It's negative 8/3. So that means the point that we want needs to have a slope of negative 8/3. Part B, to find your y-intercept, you're going to plug in the x and the y that they gave you and the slope to find the b value of the new equation that you're finding. So if we do that, we'll have 4 equals negative 8/3 times negative 2 plus b. All right. So put that over 1 and multiply straight across. The negatives cancel and you end up with 16 over 3. Now, Mr. Bailey doesn't like fractions, so what Mr. Bailey does is he multiplies this fraction by the denominator, the reciprocal, 3 over 1. The reason I do that is because that way these cancel. But if you're going to do it to that part, you have to do it to all the other parts as well. So we multiply everything by 3, and we end up with 12 equals 16 plus 3b. And from there, you just go ahead and solve it. So we have our b value, we have our m value, and therefore our final answer will be that. That is the equation of the line that would be parallel to this one because they have the same slope, but it goes through this point. All right. Same thing with the next problem. The only difference is this time we want perpendicular. And so that's going to create a little bit of a difference in the slope. But other than that, the rest of the process is identical. All right, so let's, oops, wrong color. All right. So like I said, similar steps to the last problem. It's just that we're doing perpendicular this time. So begin. So we need a slope and a b value and then an equation, right? Okay, so here's the deal with this. We want to find the equation of a line that's perpendicular to this line. Okay, now the slope of this line is 3, which is another way of saying 3 over 1. The perpendicular line, this is the symbol for perpendicular, will be the reciprocal of that and the opposite sign. So this is the slope that we're going to use for our line. Now to find the b value, the rest of it's really no different at all. That's mainly the main step there. So when you do perpendicular, you do the negative reciprocal slope. So here's my x, here's my y. That's the point that my line needs to go through. So we'll plug in the 4 for the y. We'll plug in the negative 1/3 for the m. And we'll plug in the 3 for the x. In this case, the 3's cancel. That's kind of nice. No fractions. And we get b equals 5. So final equation for that one would be negative 1/3 x plus 5. Okay. Moving along, moving along. All right, now we're going to talk about some systems of equations. You know, I don't like the way these are, so I'm gonna actually change these equations, and then I will do the problems. Okay, so I've made the correction there. All right, so substitution. This is the method for solving a system that you use anytime you have an x equals or a y equals. So in this case, we have the fact that x, oops, what's that? We have the fact that x is equal to y. And since x is equal to y, what I can do is I can replace x in the other equation with y. So if I do that, instead of 4x minus 7y equals negative 15, it becomes 4y minus 7y equals negative 15. And then we go ahead and do the math from there. 4y take away 7y is negative 3y. and then we just divide both sides by -3 and we get 5. And then you take your answer and you plug it into the original problem. It doesn't matter which one you use, but I'm going to use the top one. And if I replace the y in that equation with 5, that tells me that x also equals 5. And so the answer for that problem would be 5 and 5. Let's go ahead and take a look at number 23. Once again, I've got an x equals. By the way, it can be a y equals. If you had a y equals, you would replace the y instead. But in this case, we have another x equals. So x equals this. So now I can replace the x in the other equation with what I just circled there. So instead of 2x minus 16y equals 3, we can do 2 and replace the x with 8y minus 2 because that's what x equals. So for this one, we've got a little bit more work to do to solve it. We're going to distribute first. The 16ths cancel out and you're left with -4 equals 0. Now, when your variables go away, that either means no solution or infinite solutions. When you end up with a statement like this that's false, -4 is not equal to 0, that means there is no solution. That's the substitution method. Let's go ahead and take a look at number 24. Number 24 is so you guys can practice the elimination method. All right, so let's get to it. Gonna need some space for these ones, so let me create some writing space. Okay, so for these problems, what we need to do is we want to start, first of all, by picking a variable that we would like to cancel. Okay, so I'm going to go ahead and choose to cancel out the, let's say the x's, okay? Next thing I'm going to do is I'm going to get rid of this 24 really fast, get that out of the way. We want to take the coefficients off of the x's and reverse them. So I'm going to take the -10 in front of the x, I'm going to put it on the bottom there. And I'm going to take the -1 off of the x on the bottom there and put it on the top. And then we're going to distribute all the way across. And what that's going to do is that's going to make the coefficients of the x's become the same. So by distributing -1 on the top, I end up with 10x minus 11y equals -25. And by distributing -10 on the bottom, I'm going to end up with 10x plus 10y equals -130. The next thing we're going to do is, now that we've got those x's to have the same number, now we're going to get them to be opposite signs. So I'm going to distribute a -1 on the bottom, causing all the numbers on the bottom to change their signs. So the top equation will be staying the same. The bottom is going to become -10x minus 10y equals positive 130. So now that we've got them to be the same number but opposite signs, we can add the equations together. So when I combine the x's together, they go away. When I combine the y's together, I get -21y. And when I combine the constants together, I end up with 105. And if I divide both sides by -21, I end up with -5. So now that we have one of our variables, you're just going to take it and plug it into one of your original equations. So we have -x minus y equals 13. And since y equals -5, I'm just going to plug that in there for the y. The double negatives become positive. And then we go ahead and solve for x. There we go. So y is -5 and x is -8. Go ahead and take a look at number 23 there. Once again, we're going to need some writing space though. Okay. Oops. So, oh, that's the wrong one. Darn it, I gotta re-erase everything. Sorry, just a minute. We didn't want the 23 up there. We want 25. Okay, now we can get to work. Sorry about that. Here we go. So same process as the last one. Take a variable you want to cancel. Let's cancel the x's again. Take the coefficients off and reverse them. So I'm going to take the 6 from the bottom, put on the top. Take the 2 from the top and put on the bottom, and multiply straight across. And so what we end up with is 12x plus 30y equals negative 48 on the top. And on the bottom we get 12x plus 30y equals negative 48. And then now that we got the x's to be the same, we're going to multiply one of the equations by a negative. So I'll multiply the bottom one by a negative all the way across. And that gives me 12x plus 30y equals negative 48 for the top still, because I didn't change the top. But the bottom, all the signs on the bottom equation will now be different. So now that we have our equations matched up there, we're going to go ahead and combine the like terms. Those cancel, and these cancel. So we're left with 0 equals 0. And as we mentioned on number 23, when both variables go away at the same time, that means either no solution or infinite solutions. In this case, since we had a true statement, the answer is infinite solutions. Okay, so for number 26, it says sketch the graph of a system of equations that has a solution of negative 1, 2. So what we're going to do is we're going to plot that point, negative 1, 2, and put a dot there. And basically what I'm going to do is I'm going to draw two lines that cross at that point. Because that's what a system of equation is. The solution is the place where those two lines cross. Let's take a look at number 27. For number 27, they want us to sketch a system of equation that has no solution. Well, if it has no solution, then the two lines would not cross. So basically what you need to do is draw any two parallel lines, and that would be an example of a system of equations that has no solution. So just a different way of thinking about the solution to systems of equations, thinking about it graphically instead of numerically. All right, let's go ahead and take a look at number 28 here. All right, number 28. My little brother was building a puzzle. After he left, I started building it. After 30 minutes of patiently working, I completed 30% of this puzzle, and by 60 minutes of patient work, I had completed 50% of the puzzle. And our goal is we want to write a linear function to model this story problem where x represents time and y represents the percentage. Okay? So this is a problem where I give you 4 numbers. And when I give you 4 numbers, you want to start setting your problem up like this. X represents the time. Y represents the percentage. And basically what we're going to do is we take the 4 numbers out of our word problem. We're going to put them in the table there. So after 30 minutes, 30% of the puzzle was done. And after 60 minutes, 50% of the puzzle was done. Well, once you have that, to find the equation of the line, which is what it's asking us to do in part A here, it's pretty straightforward. What you're going to do is it's straightforward if you did the rest of the study guide before this. You're going to find your slope. This is your x1, this is your y1, x2, y2. And you're just going to go ahead and plug them into the old formula that we've been using. So y2 minus y1 over x2 minus x1. That gives me 20 over 30, which is 2/3. Next, we want to find our y-intercept. So you're going to take one of your points, 30, 30. You're going to plug in the 30 for the y. You're going to plug in your slope. And you're going to plug in the 30 for the x into that y equals mx plus b formula. Go ahead and start solving for b. 60 over 3 reduces to 20. And we get b equals 10. So the equation of the line, which is our answer to part A there, is y equals 2/3 x plus 10. All right, let's go ahead and take a look at the next one. What percent of the puzzle did my brother complete? Okay, now that question is worded in a sneaky way. So here's the hint. That's how much was done before I started. Now remember, x represents how long I've been working on the puzzle, and y represents the percentage that has been completed. Okay? So now, what percent of the puzzle did my brother complete? That means before I even started, which means that time equals 0. So if it's before I started, then that's when time equals 0, because we didn't start counting the time until I started the puzzle. So that's at t equals 0. Now, but we're not using time, right, as a variable. We're using x. So the variable that we're looking at here is x equals 0. So what you're going to do then is, for part B, you're going to plug 0 in for the x, because that's when the time equals 0 and x represents time. And so the answer is 10%. So my brother had completed 10% of the puzzle. And I went ahead and did the rest after that. The next question is kind of like it, but it's kind of like the opposite at the same time. How long will it take me to complete the puzzle? Okay, I should have put a hint here. That might have been helpful. If I've completed the puzzle, what percent of the puzzle is done? 100%. Right? If I've completed it, then 100% of the puzzle is done. Now, since that's a percentage, which variable is that, x or y? That's y. So basically, if y equals 100, what will x be? Because x is the time. So that's the question here. So we have the equation y equals 2/3 x plus 10. And the question is, how long, what's x, how long will it take for me to complete the puzzle? In other words, 100% of the puzzle. So I plug in 100 for y, because y is the percent, and I've completed 100%. And I need to solve for x, which is the time. So step 1 is going to be to go ahead and minus the 10 on both sides. That's pretty easy there. Step 2, how do we solve this? I would multiply both sides by 3 over 1, because here those will cancel. So now I'm going to be left with 270 equals 2x. And if I just divide, I'm going to get 135. So x equals 135. And remember, that's time, and our time is being measured in minutes. So that's 135 minutes is the answer. So for me to complete 100% of the puzzle, it will take me 135 minutes. So with these last two types of questions, you're given a number. You have to figure out what variable that number is. And once you know what number it is and what variable it is, you just plug that into the equation and solve for the other one. Okay? That's it. We'll go ahead and do the next word problem. And I told you there's two types of word problems. This first one that I did is the one where I give you 4 numbers. This one over here is the one where I give you 3 numbers. It's actually a little bit less work. So let's go ahead and take a look at that one next. All right. So on this problem here, it says on average I can read at a rate of 0.6 pages per minute. Now when you see that word per, or it could be the word every, but either way, that means that's our slope. So my slope is 0.6. Now the slope can either be positive or negative. So if the amount of whatever you're looking at is increasing, then it's positive. But if the amount you're looking at is decreasing, then it's negative. So if I'm reading a book, is the number of pages I'm reading increasing or decreasing? Well, obviously over time, if I'm reading my book, the number of pages that I've read will have increased. So this is going to be a positive 0.16. So that's going to be my slope. All right, now the next thing is that it says today I picked up where I left off yesterday. So after reading for 30 minutes, I was on page 112. Part A says write a linear function to model the scenario such that x represents time, so the 30 minutes here is my x, and y represents pages, so the 112 is my y. So I've got an m, which is 0.6, I've got an x, which is 30, and a y, which is 12, and we want to write an equation. And how do you do that? Well, we've been doing it quite a bit in this study guide. So the first thing you do is you write down your slope, 0.6. In this case, it's a positive 0.6 because the number of pages I'm reading is increasing. The next thing I'm going to do is I'm going to find the b. So we're going to plug in our y value for y. We're going to plug in our slope. And we're going to plug in our x value for x to the y equals mx plus b formula. And then we're going to solve for b. So 0.6 times 30, let's see, what would that be? 6 times 30 is 180. So move the decimal over once, that'd be 18, I guess. And then we're going to subtract 18 on both sides. All right. 94. So it looks like b is 94. So my equation then is going to be y equals 0.6x plus 94. That's part A. Part B. What page did I start on today? Okay, so this is a formula that will tell me what page I'm on at any time. Actually, let me say that again. This is a formula that will tell me what page I'm on at any time. Today. So this formula is only for today. So if it says what page did I start on today, well, at the beginning, I want to know what page I was on. So what page? What they really are asking me to find there is they're asking me to find what y equals, right? So if they want me to find y, that must mean they told me what x is. So what is x? And remember, x represents time. Well, the problem doesn't give me a number, but it says on what page did I start? And at the start, how many minutes have I been reading? The answer is 0. So for this one, you're going to plug 0 in for the x, and you're going to solve for y. So if I do that, this goes away, and I'm left with 94. So that means I must have started at page 94 at the beginning of the day. That must be where I left off yesterday. Okay, so let's go ahead and take a look at the next question. So for the next question, it says, part C, if the book has 223 pages, so they're telling me that y equals 223, how many more minutes will it take me to read it? How many minutes will it take me to read it? That's an interesting question. Well, let's do it this way. In other words, they want to know how long it's going to take for me to get to page 223. So what's x? So I'm on page 223. I want to get to page 223. How long will that take? So I'm going to take my formula. I'm going to plug 223 in for the y. And then I'm going to solve it. I think that's right, isn't it? No, it's 9. Mr. B. Okay. 21 take away 9. What's that going to be? I don't know. 129. Got to divide by 0.6. I don't want to do that. I'm going to use a calculator. That's it. The numbers are too weird. So 129 divided by 0.6. 215. So x equals 215. And that's minutes. So it would take me 215 minutes to read to page 223. But remember, that's starting today. I started off today on part B. We started off on page 94, right? So in order for me to get from page 94 up to page 223, then that will take me 215 minutes today to read it. Okay, so that's what that means. All right, so once again, on these last two questions, after you have your equation, you have two variables. One of them I'm going to tell you what it's worth, and the other one you have to solve for. The trick, though, is that you have to know what variable it is. So if I say it's 223, you need to know that's y, because I tell you up here that y represents pages. Another thing is that sometimes I might say, what's the starting amount? And that's like a sneaky way of saying that the time equals 0. Okay, so you got to watch out for those two things. All right, last problem on our study guide. Linear regression or lines of best fit. So as here it says, find the line of best fit for the following data. Determine if the relationship between the variables is positive or negative or neither. Okay, so we're going to plot these points. -6, -1 is first. -4, -1. -2, -2. 0, 0. 1, 2. 4, 3. Now, we're estimating here, you guys. And so, since we're estimating, there's not a right answer to this, but there's definitely wrong answers. So, for instance, this would be right. You drew a line that was as close as possible to the points that are there. But if you drew something like this, you're not getting any credit. You missed it, because the line needs to be close enough to the points to be reasonable. Okay. The next thing that we're going to do is we're going to find the equation of that line. So pick any 2 points on the line or that are closest to the line and use those points. So I'm going to use the point 1, 2 because that's on the line. And I'm also going to use the point -4, -1 because that's also on the line. The rest of them I don't care about now. I'm going to use those 2 points to estimate what the equation of that line would be. So what I would do is I would say, this is x1, y1, x2, y2, and then I would find my slope, my b, and equation. Okay, so y2 minus y1 over x2 minus x1. Double negatives become positive, so I end up with 3/5 for my slope. To find b, we plug in a y. We plug in our slope, and we plug in an x to the y equals mx plus b formula, and we solve. So 1 times 3/5 is just 3/5. And then we're going to multiply everything by the denominator of 5 there. So I'm going to start here, and the reason we're doing that is so the 5's cancel and I don't have a denominator. But if you do that there, you have to multiply everything by 5. So 5 times 2 on the left is going to be 10. And 5 times b is going to be 5b. Oops. From there, we just solve. So b equals 7/5. Now that's an acceptable answer, but it's not the only one I would accept. Maybe you just looked at the graph and you said, oh, well, it looks to me like the y-intercept is 1. So instead of calculating it, maybe you just looked at the graph. If you did that, I'll still give you credit if you put 1. It just has to be close. 7 divided by 5 is like 1.4, which is pretty darn close to 1. So we're estimating, remember, so I don't care if you get that one right. Exactly, okay? So now the next thing we're going to do is we're going to write our equation. So our answer would be y equals 3/5 x plus 7/5, or you could say 3/5 x plus 1. But honestly, even those two are not the only answers. Here's what I'm looking for on this one. You have to be close. So if your slope isn't really close to something like 3/5, and if your y-intercept isn't something pretty close to 1, then something went wrong. Okay, so it has to be reasonable. But yeah, since we're estimating, it's not going to be exactly that. So there it is. That is your study guide. Your test won't be this long, but I like to include a lot of extra problems on the study guide just to give you guys more practice. But your test will usually be anywhere from 15 to 20 problems, so that's what you guys can expect. Anyway, that's it for that, and we'll see you guys on test day next Monday. So make sure you're in class on time. Have your technology ready, because I'm going to be emailing you the test first thing in the beginning of class. See you then.